Good afternoon, guys. This is Mr. Holmes coming to you all, getting ready to talk to you about how to multiply rational expressions. All right. Please keep in mind that a rational expression, by definition, is just an expression where there's a fraction involved with two expressions on top of one another. All right. So what I want to do, I want to explain how to multiply rational expressions, then give you one to do yourself and see how well you do. So, given any rational expression, you have to multiply numerator times numerator, denominator times denominator, and simplify. So here, what I want to do here, I want to start off with giving you an expression. Here I have 8x cubed y divided by 2xy squared times 7 x to the fourth y cubed divided by 4y. This is the expression that we're going to talk about when we're multiplying rational expressions. And we're going to multiply these rational expressions. We're going to multiply again numerator times numerator, denominator times denominator. So we multiply 8 times 7. This is how I get my 56. Keep in mind when you multiply variables that are the same, you should add the exponents. So here I have 3 x's, here I have 4 x's, so I have a total of 7 x's. Here I have 1y. Even though you don't see the 1 here, it's still 1y. You have one y here, you have 3 y's here. This gives me a total of 4 y's. Divided by I'm going to multiply coefficient times coefficient. 2 times 4. This is how I get my 8. 1x here, no x there, so I have only 1x. Here I have 2 y's because of my y squared. Here I have 1 y, so that gives me a total of y cubed. Now that we've multiplied two rational expressions, keep in mind that we must make sure that we simplify. Meaning, if we can divide, we must divide. If we can reduce, we must reduce. In this case here, what I'm going to do is I'm going to go ahead and divide, because 56 can be divided by 8. 56 divided by 8, this gives me a quotient of 7. Here, when we divide variables that are the same, you should subtract their exponents. Here I have an exponent of 7. Here I have an exponent of 1. So you always do the numerator's exponent minus the denominators. So 7 minus 1. This gives me x to the 6th power. Lastly, here I have y to the 4th divided by y cubed. That gives me y to the 1st power when you do 4 minus 3. And there you have it, guys. That's part of your final answer. Notice I used the word part, because here, keep in mind that you cannot, neither one of these variables cannot be equal to 0. If either one of these variables are equal to 0, my entire denominator becomes 0. That being the case, we must make sure that x cannot be equal to 0 and y cannot be equal to 0. If either one of these are 0, again, they will cause my entire denominator to be 0 when you multiply. And it's impossible for you to divide by 0. So here you go, guys. That's your final answer. 7x to the 6y, where x and y cannot be equal to 0. What I would like to do now is give you guys one to try and emphasize. And if you understand the concept, congratulations. So what I want to do now is go ahead and give you one to do. So try this one on. Here I have 3 x to the 5th y squared divided by 8xy times 6xy squared divided by 9x cubed y. What I would like for you to do is go ahead and multiply these two rational expressions. Now what I'm going to do here, at this time, I'm going to ask that you pause this video, and when you are done with your problem, go ahead and unpause it and watch me work it out. Alright guys, as of right now, you should have unpaused the video at this moment and begin watching me work this problem out for you. Alright, here I'm going to multiply numerator times numerator, coefficient times coefficient, 3 times 6. This gives me my 18. Here I have x to the 5th times x. This gives me x to the 6th power when I add their exponents. Keep in mind, when you multiply, you should add the exponents, and when you divide, you should subtract them. Here I have y squared times y squared. This gives me y to the 4th power. That's my numerator. My denominator, I'm going to multiply coefficient times coefficient, and I'll get 72. Here I have x times x cubed. This gives me x to the 4th power. I have 1y times 1y. This gives me y squared. Now, I know some of you guys may ask about this x and y, and how do I get that to be equal to 0? So what I would like to do is explain it just a little bit different, and we'll come up with the same type results, okay? So I'm going to explain this problem here a little different than I did this one. Now, what we want to do is we want to look for common factors. Remember, the factors are the two items that must be multiplied to give you the numbers or terms or variables that you have. In this case here, 2 factors of 18. I'm looking for common factors between 18 and 72. I know my common factor between 18 and 72, the largest. We want the greatest common factor. All right, in this case here, I know 1 times 18. All right, 1 times 18 is 18, and 4 times 18 will give me 72. This here, notice I have 18 for them both. 4 times 18 is 72, and 1 times 18 is 18. So that's how I broke down 18 and 72. I'm going to put my little dot here for times. Here I have 6 x's in my numerator, but only 4 in my denominator. What I want to do is I want to show you guys common factors. So I'm going to take this x to the 6th and break it up in one group of x to the 4th and a group of x squared. So here I'll do x to the 4th power times x squared. Again, the reason why I'm doing this here is because I have only 4 x's at the bottom. And I want to show you guys common factors. Now granted, we can just subtract the exponents and get the answer, but the concept is to show you guys how to use common factors to help you simplify rational expressions via multiplication. Here I have 4 y's here, I have 2 y's in my denominator. So in my numerator, I want it to be in groups of 2. So here I'm going to have y squared times y squared. That equals out to my y to the 4th power. In my denominator, I only have 1 y squared. So here I'm only going to put 1 y squared. And there you have it. Now, the very last thing that I want to explain to you guys is common factors. Whenever you see two factors that are common, you're going to divide each one of them evenly. We don't use the word cancel because most students believe cancel goes to 0. So we're going to say divide evenly every time you see a common factor. So here both these have 18, so 18 divides itself one time. Here I have x to the 4th divided by x to the 4th. Both of these are common factors. Therefore, we can let those two divide each other out evenly. Here I have a y squared here and I have a y squared here. Up here I have 2, but down here I only have 1, so I only can take out 1 y squared. Everything else, if it's in the numerator, you'll leave it in the numerator. If it's in the denominator, you would leave it in the denominator. Here I have 1 times, well, this here will become 1. This will become 1. This will become, stay x squared. This becomes 1. So the only thing that I'm really multiplying is 1 times x squared times y squared. X squared and y squared are the only two variables that are not marked off. So that being the case, that will be part of my final answer. Here, x squared, y squared in my numerator. In my denominator, notice both my variables have been divided into evenly with their common factors. The only thing that I was left with was my 4. So at the bottom, I'm going to have 4. And here's part of your final answer. Notice I used the word part. Every variable that you happen to divide evenly, that you mark off, you have to take those variables and set them equal to 0. This is just another way for you to understand how to find out which variables will be equal to what. Because these two variables were marked off, we're going to take them both, set them equal to 0, and that will tell you what cannot be equal to 0 in your denominator. In this case, my x to the 4th is still x. So in this case, x cannot be equal to 0, and my y cannot be equal to 0. I hope you guys enjoyed this second problem. I hope you guys got a better understanding on how to multiply and simplify rational expressions. This is Mr. Holmes explaining rational expressions. And if you know me, you know what I'll say. I hope you enjoyed this video and have a blessed day.